All right. So we're talking about calculus today. We're going to refresh your memory of all things calculus related. Let's get started. So, all right. So the main concept from calculus that you need to remember is the power rule. This is in your reference booklet. This is how we found the derivative of a function. Remember, you take your exponent, you bring it down to the front, and you subtracted 1 from your exponent to get your derivative, right? So if it was x to the third was your function, your derivative would be what? 3x squared, because you basically take the exponent, you bring it down to the front, and then you subtract 1 from your exponent, and that's how you get 3x squared. And do not forget the notation for derivative was the apostrophe. Not to be confused with complement. Not to be confused with complement, because it would apply with a function. Okay? So this right here, this notation means derivative. Live it. Love it. Yes. Let's practice power rule.
Yeah.
On your desk. Okay?
I want to test on power rule. Can we do that? Like a quiz right there.
Find the derivative of this. All right, so what's the derivative?
11x. Okay, 10. Yeah.
11x to the 10th. Very good, because again, you bring the exponent down, you subtract 1 from your exponent. Try this one on your desk. All right, so what's the derivative of this one?
12x to the third plus 12x.
Plus 12x, very good. So whenever there's a number in front, like in this case, there's a 3. When you bring the 4 down, what do you do with the 4 and the 3? Multiply them. That's how you get 12. For that one, that's also how you get 12 for the second one. You subtract 1 from each of the exponents. Very good. Clear your desk. What about this one? You guys, if anything, write this down. I mean, at this point, it's a little bit too late because you all have already gone past like the point where you shouldn't still be taking SATs or ACTs or anything like that. But this is the rule. If you're going from radical form to exponent form, whatever's the root is the denominator, whatever's on the inside is the numerator. So in order to do the derivative of the cube root of x squared, you have to rewrite it in the exponent form because it needs to be a power. Then you can apply your power rule, which says to take the exponent, bring it down to the front. So then that becomes 2 over 3x. Then you subtract 1 from your exponent. 2/3 minus 1. How do you subtract a fraction from a whole number?
You turn the whole number into a fraction. 3 over 3.
3 over 3. What's 2 minus 3?
-1.
So this turns to a negative 1/3. Okay? And then you don't really want to deal with a negative exponent, so you make it positive. Pull them back from old concepts.
You bring it down.
You bring it down to the denominator. Now, isn't there a number already in the denominator? There's a 3. So when you bring it to the denominator, you're going to have the 2 is still going to be at the top. The 3 is in the denominator already, but now you can join it with the x. And what happens to the exponent?
It goes positive.
It turns into a positive. And then that is your derivative. If we had to take the derivative again, then yes, we would bring it back up the exponent, but for the derivative, just the first derivative, that's going to be our final answer.
You don't negate.
Here's the next one. All right, for this one, okay, this is another one that you have to adjust. You have to adjust this part before you can actually take the derivative. How do we adjust that? Yes, you have to bring up that x. It cannot be in the denominator when you're trying to apply the actual power rule or take the derivative of it. So if you bring it up to the top, it turns into a negative 1. And now from there, we can actually take the derivative of this function. 0.5x. What's the derivative of 0.5x? 0.5. Okay? And then for this one, since it's a -1, we can bring it to the front. When we bring it to the front, -1 and -8 turn to a what? Turns to a +8. And then we subtract 1 from your exponent to turn it into a what? A -2. We don't want to leave that exponent as a negative. How do we turn it to a positive?
Bring it to the bottom.
Bring it to the bottom. Does everything go to the bottom?
No, just the exponent. Or just the variable in the exponent.
Just the variable and the exponent. And then that is our derivative. Questions? Alright. I think we got one more before we move forward.
Okay. Wait, I have one question.
Yeah.
Why did it go to a -2?
Because it was already a -1 and you always subtract 1 from your exponent.
Did you bring it up? Oh, no, just general. Okay.
Just in general.
All right.
Yeah, so yeah, -1 -1, and that's how we ended with the
And you brought it
-2. And then we brought it down because we want it to be positive. All right, last one. All right, what's the derivative of this one? 2x plus a over x squared. Very good, because this has to be written as ax to the -1. And so when you bring that exponent down, that's why the negative turns into a positive, and then you subtract 1 to get a -2, and you bring it back down to the bottom to make it positive for a +2. Good stuff. All right, questions on power rule. Okay, you need a power rule in order to do anything else from there. Okay, that was one of the main principles of calculus. Okay. The derivative was involved with gradients, tangents, and normal lines. Remember, gradient meant what? It meant the slope. It meant the derivative. So anytime it asked you to find the gradient of a tangent line, you had to basically find the derivative of the function. Okay? Gradient meant slope. Slope meant the derivative, aka the process that we just practiced. Okay? Finding gradients at particular curves, at particular points on a curve. What you had to do was you basically had to plug in the x value into the derivative. Once you found the derivative, you plugged in the x value, and then that gave you the slope of the tangent line. It gave you the gradient. Okay? That's how we use the derivative to the next level. Okay? So we're going to practice doing that to make sure everybody has that down. Finding the gradient. How do you find the gradient again?
Oh, yeah, y2 minus y1.
We're in calculus. We're not in geometry. Huh?
The derivative.
You find the derivative, and then you do what? Plug in what?
Plug in that to the original.
Plug in the x value into the derivative. So, no, that's later. That's coming up. So you're given that f of x equals ax to the third plus 2x minus 1. We have to find f prime of 2 on your desk. All right? So first thing you have to do is you have to find the derivative. What's the derivative of this function? Plus 2. Bring down the exponent. Subtract 1 from your exponent. And then 2x turns into 2. And so then from there, you want to plug in the value of 2 to figure out what is the slope of that tangent line at 2. So when you go to plug in 2, 2 squared is 4. What are you going to do with that 4 and that 3? To get? So 12a plus 2. Yes, a does have a particular value. I basically pulled this from like a part A, B, and C, where later on you do figure out what the value of a is. I think I put it up here later on, but if I don't, then just realize that, you know, you can't find the value of a.
Why did it have to stay like that? Can't you do 14A?
You can't, because a is some number, and we don't know what that number is. So a could be 1, it could be 2, it could be 1/2. And so whatever that number is, we are going to multiply by 12 and then add 2. But we don't know if it's going to be a 14. Like, we can't turn it into 14a, because that will just affect the whole number altogether.
Oh.
Yes, order of operations. Yes?
So what you did was you plugged in 2 and then
simplify. Yep, because every single one of these things are being multiplied together. A is being multiplied to x to the third. So when you bring it down to the front, 3 is getting multiplied to a, and then also to x squared. So that's why we're able to multiply all the things together to get 12. All right? Let's try an actual IB problem. So a curve is described by the function. So we have a function here, and it asks us to find the derivative. Okay, this was one of the questions I pulled from an old IB exam. It was A and a B. Clearly, it was a paper 1. Okay, and you had to find the derivative. Okay, I would probably suggest you bringing up that x squared to make it a -2. Did you guys do that? So in that way, when you took the derivative, what did you end up getting?
So 3x plus 4 over x.
Well, so 3 plus 4 over x to the third.
Yep. So 3 plus 4 over x to the third. Since it's a 3x, when you take the derivative, this turns into a 3. In this particular order, no, you can have 4 over x to the third plus 3. That would be fine. Yes? Because remember, since it was a -2, when you bring it down to the front and you multiply, it turns into a positive. Question on finding the derivative. So then it says the gradient of the curve at point A is 35. Find the x-coordinate of A. 35 represents the what? It represents the gradient, aka it represents the derivative, which we just found. So in this particular case, we're not going to plug in 35 for x because it's asking us to actually find x. So we actually have to set it equal to. Very good. So you have to set it equal to 35 because that represents the gradient. And what we found in part A was the gradient function. So now we solved this. Hopefully you remember your skills of solving an equation. What do you start with? Minus 3. So I'll have 4 over x to the third equals 32. Then what?
Flip the thing
Flip it
to the
over
top.
and then multiply it by 4.
Multiply by x.
I thought you could do a
Flip the thing
reciprocal
to
and
the
then
top.
No, you don't divide by 4 because 4 is at the top.
Multiply
by
by
4,
x
right?
to the third.
You multiply by x to the third. You need to get rid of the denominator first.
oh.
Okay? And you can't divide by 4 because that's not how those problems. It's not how those problems are done. I don't know another way to explain it. Don't do that. Don't do that. What you should be dividing is what? The 32. To have 4 over 32 equals x cubed.
So now we got a cube x.
Now we got a what?
You got a cube rooted.
You got a cube rooted.
So it's like separate, because I was doing the 32x to the third together. That's right.
You can reduce 4 over 32 and then cube root it, right?
Yes, you could reduce it. What does 4 over 32 reduce down to be?
1
1
over
over something.
1/8. And maybe that might be a little bit easier to see what the cube root of 1/8 is.
1/2.
It's 1/2.
Wait, what?
1/2 times a half is 1/8.
Think about what's the cube root of 1? 1. Cube root of 8, 2. If you did not know that, of course you can use your calculator. Where is cube root at in your calculator? Math.
3.
Option 4. You're doing a cube root. So you do 1 divided by 8.
I knew that.
And you get 0.5. Convert it to a fraction. Math, enter. All right. Questions on this. That's the x-coordinate of where the slope of the tangent line is going to be 35. That's basically what that is.
I got 2.
Probably because you had divided 4 when it should have been the other way around. So remember, get rid of your denominator, not the other way around.
Can't you get rid of it by like flipping it like that one?
Doesn't work same way. If you divide it by 4, you'll end up getting a completely different number as you saw. Any other questions on gradient? That part, gradient part. Going up another level to tangent lines and normal lines. These were actually writing the equation of the line that's touching the curve at a particular point. Remember, one way to write them was using point slope form. Y minus y1 equals m, parenthesis x minus x1. Of course, you can always write it in y equals mx plus b. Could write it in standard form. Just depends on what the problem asks you to do. If it doesn't say a way, point slope is the easiest. But you can't write it in the slope intercept. Remember, normal lines, you write it the same way, but the slope was the opposite reciprocal of the tangent line slope. Okay? Normal lines were the opposite reciprocal. So once you figured out what the slope of your tangent line was, you would have to flip it and change the sign in order to get the slope of the normal line, but you could still use the same point as the tangent line. Okay? So don't forget about those. Yes, so like I was saying, you can either write it in this form, which is point slope, or you could write it in slope intercept form. Either one. Now, if the question does tell you to write it in a certain way, then you got to write it that particular way. Okay? But like I said before, if it doesn't tell you the way to write it, one of the easiest ways is to do point slope. Let's take a look at an example, such as this one. And it just so happens that form there. All right? So, I'm going to let you guys do A and B to start, and now join back in for C. All right, what's the derivative of function? 4x to the third. We should be good with power rule by now, right? Refreshing our memory, remember how to do it? Now it says the point 2, 6 lies on the graph of f. Find the gradient of the tangent to the graph at P, which means you have to do what? Plug in 2. Take the x value and plug it in. So order of operations says to do what first? The exponent. So we're going to cube 8 and then cube 2, which is 8, and multiply by 4 to get what? 32. 32 is the slope of the tangent line. But it asks us to write the equation of the normal line, which means the slope of the normal line is going to be what? Negative 1 over 32. That's what I was trying to say on the previous slide. The normal line is the opposite reciprocal of the tangent line. Okay? So we take 32, we flip it, and we change the sign. So that's the slope that we're going to use. And then the point that we're going to use was what was given to us from before. Okay? So now let's write this in point slope form. I know we have to go to standard. Let's just go ahead and write it in point slope form. Y minus y1, what is it? 16 equals m. Good. X minus 2. Now, if it just said write the equation of the normal line, we could write that and we would be done. But we got to put it in the standard form. So what am I going to do to put it in the standard form? Multiply. I'm going to distribute this. That's going to give me a negative 1 over 32x plus 1 over 16. And now standard form, everything has to be on the same side, so I'm going to add 16, and I'm going to minus y to get it all on one side. So I'm going to add 16 to 1 over 16. I'm going to subtract y from both sides. I know it's kind of congested down there. Let me rewrite this. I'm going to have a negative 1 over 32x minus y plus 17 over 16. That doesn't sound right. What's 1/16 plus 16? That sounds a little better.
16. You want to get fraction?
Yep.
257 over 16.
257. 257 over 16? Okay. Now, we're still not done. No. Why are we not done?
Because it's y.
You have to turn it
Negative y plus, right? You have to put, I don't know.
Because there's a negative number in the front.
You have to put it in another form.
Well, it actually could be negative in the front. It says that A, B, and D have to be what?
Positive.
No, they got to be integers. Integers are what types of numbers?
Numbers.
Not zero.
Negative
Whole-
or positive whole number.
Negative or positive whole numbers. So the numbers could be negative, but they cannot be fractions. So we have to get rid of all of those fractions. How do we do that?
Oh, you times.
Multiply everything by what number? 32. Because when I multiply negative 1 over 32 by 32, what does it turn into?
1.
A negative 1.
Oh, yeah.
32 times negative y turns into a
32y.
negative 32y. And then what's 32 times that large fraction over there? I mean, y'all got the calculators in front of you all, right?
514.
Yeah, 514.
And that is our equation in standard form.
So you have to.
All because of that right there.
So we would have gotten points on it. Would have gotten the whole dang thing.
No, you wouldn't have gotten the whole thing wrong. You definitely wouldn't have gotten all your points. Now, if you were able to get everything at least onto one side, like what we had before we multiplied everything by 32, you should have been able to get, at least 2 out of the 3 points. But you need that all of them to be whole numbers in order to get that last point.
So it says integers, just make it one number.
Yep. And a lot of times that's how they're going to ask you for standard form anyway. They have to be whole numbers.
Okay. And why can't you multiply by 16?
Because you'll still have a fraction with that one.
Gotcha.
You multiply by the denominator.
It's on you to do on your own. Okay? So your desk, and try this one.
Oh my gosh.
No, they go, what are your skills? I'm like, I'm very good at multitasking. What do you mean? I'm texting and driving.
The equation of the curve is given as 2x squared minus 5x plus 4. You have to find dy dx, aka the derivative. What is it?
4x plus minus 5.
Then they give you an equation of a line. Now, they're not just going to give you just any old equation of some line. This needs to be used to help you answer the future question. It says find the x-coordinate of the point on the curve of the original problem where the tangent is parallel to L. Parallel lines have what?
The same slope.
So you have to figure out what is the slope of this line and then do what after you figure it out? Set it equal to the derivative. How do you find the slope of this line?
You gotta get it at y equals mx plus b form.
So to do that,
Form.
no, you're right, y equals ms plus b form. So to do that, what do I need to do?
Minus 1.
You gotta subtract 6x to get it on the other side.
Subtract
And then
6x.
divide by 2.
By 2y.
So negative 3x minus 1/2. Not really concerned about the 1/2. I'm only concerned about the,
Slope.
which is,
Negative 3.
so I need to take negative 3 and set it equal to the derivative. That's how you find the x coordinate. How do I solve this?
Already add 5.
To get,
2.
then,
Get 1/2.
and the x value is 1/2, where the slope is going to be parallel to that equation L. Questions?
Could you have graphed it?
Could you have graphed it? If you had graphed the derivative, Oh, if you had to graph the original function, that's pretty much all it would have given you. Was just the function. You wouldn't have been able to use the calculator to help you figure out that x would have been 1/2. That would have been parallel to that particular line. You had to do some algebra to get you there. Oops, didn't mean to do that. Y'all doing the most. All right, turning points. Turning points are basically your maxes and your mins. To find your turning points, you set the derivative equal to 0 and you make a number line. You guys remember doing that?
Yes.
With the test points, and if it went from positive to negative, you had a max, and negative to positive, you had a min. You guys remember doing that?
Yes.
Okay. So again, turning points are your mins and maxes. Set the derivative equal to 0 to find exactly what the x coordinate is of those mins and maxes. And the number line was to help you determine what type they were.
This is the number line.
This is the number line, yes. How do you find the y coordinate of the max and min? What did you have to do? Because once we set the derivative equal to 0 and we solved it, we would find the x coordinate.
You plug the x into the
Original.
You plug the x into the original to get the y coordinate. Okay? Now you guys are allowed to use your calculator for the entire test, so if you ever forget how to find the maxes, you can always use your calculator and use that feature of the calculator, but you want to graph the original function if you're looking for a max or a min. Okay? This will be something that to use if it's like a show problem, show that it's a maximum, show that it's a minimum. Derivative set equal to 0, make your number.
Not a show problem. We use method points.
It's a possibility that you could lose a point here or there because if you do everything straight to your calculator, you could get the G2 instead of the full A3. But, you know, it's something that you just have to decide if that's something you want to take, something you want to risk. We're good?
What if you don't know if you don't know how to show it? Is it better to get the right answer on the calculator or try to show it or like what? Try to show it and then get the right answer on the calculator?
Yeah, I will try to show it and then get the right answer on the calculator to confirm it, or confirm it on your calculator too. All right? Something else that goes along with that, if the derivative is greater than 0, so in other words, when you make that number line and you know we pick out our test points, whatever they are, if it is greater than 0, if it's positive, that means the function is increasing. If it's less than 0, that means it's decreasing. That's how we determine whether or not there was a max or a min. Sometimes they may ask you, where is the function increasing? Look at the derivative. If the derivative is positive, it's increasing from those respective intervals. If it's negative, it's decreasing on those respective intervals. If it equals 0, that means you have a turning point. That means you actually have a max and a min, or a min. Okay? So those things all go together. If they ever ask you about increasing or decreasing, that is also a part of it. All right.
They just don't want you to pass?
No, you can pass. You just
No, I'm saying they don't want you to pass.
no, they do want you to pass. They want you to earn it.
They want to.
They ain't gonna give it to you. That's the truth.
They want your head.
It asks you to find the gradient when x equals 2. Gradient means what?
Slow.
Which means what?
You have to do the power thing.
You have to do the derivative. So you should have done the derivative to start out with, which was this. And then you plug in 2 to actually find the slope when x is 2. So when you go to plug 2 in, what do you end up with?
4 plus 12 minus 10.
Which is?
14.
And that is the slope of your tangent line when x equals 2, aka what you need to use in part C when it asks you for the equation of the tangent line. Because in order to write the equation of a line, you need a slope and you need a point. Okay? Now, real quick, since I need A to answer C, I'm going to jump down to C and answer C real quick. Because again, this is the slope of my tangent line, this 14 right here. I have an x coordinate, but I don't have a y coordinate. I need an x and y coordinate to write the equation of my line. How do I find the y coordinate? Plug it into the original. Anytime you have an x value and you want to know the y value, plug that value into the original. When I plug 2 into that x cubed plus 3x squared minus 10x, what do you get?
I got 0.
Is it 0? So then that's the y coordinate. So that's the point that you're going to use, 2, 0. That's the point. 14 is your slope. So to write the equation of your line, and it doesn't tell you which way to write it, y minus 0 and that's it. You're done. If you want to distribute and you want to put in the slope-intercept form, that's fine, but you don't have to because it doesn't tell you which form to write it in. But that's the equation of your tangent line when x is 2.
And if you wanted to put it in standard,
You would have to
you
distribute.
it and then you take the y and put it over and make you don't unless it says it has to be an integer, you don't have to do anything else, right?
Correct. All right.
Standard is the AX plus.
I do this some other way.
Any questions on A or C before I go to B? Yes.
So I went to the calculator and I drew the tangent line and then it told me the equation here at the bottom. Does that work every time?
Does it work? If you remember the process, yes, but that won't probably get you all the points because you used your calculator to get that.
How many points does this question work?
I don't remember. In B, it says to find the x value, both the max and min points, and distinguish between them. So when you write them down, you got to say which one's the max, which one's the min. Hence why it says distinguish. To find the maximum points or the minimum points, you take the derivative and you set it equal to 0. That's how you would do it algebraically. That's how you would do it algebraically. Now, does this factor 10, 3, 5, 6, 2, 15? No. This one does not factor, so you would have to use your calculator in order to do this. One way you could do it is this right here. You could actually figure out where these two curves intersect each other to find that x value. Okay? Another way you could do it is you could plug in the original function and see where the max and mins are by using that feature. Either one will still get you the x coordinates of your maximum and the x coordinate of your minimum. Okay? Since we are talking about derivatives, I'm going to use the fact that I'm going to take the derivative, which was 3x squared. What was the rest? Plus 6x minus 10. I'm going to use this, and I'm going to put 0 into y2 and figure out where those x coordinates are, where they intersect. Almost look like it's going to be whole numbers, almost. I'm going to use the intersect feature of my calculator, second trace, option 5. I'm looking for 2 intersection points. I'm going to find this first one. Negative 3.08. Did you guys get that? It's the same thing that you would get if you had graphed the original and found either your max or your min. And then I'm going to do the exact same thing for the other point. Second trace, option 5. $1.08. Did you guys get that?
If you put the whole coordinate, would you get it wrong?
Yes,
Okay.
because it's asking me for the x value. Good question, though. Yes.
I plugged in the original into the graph, and like mine had like two.
They had a max and a min, or 2 maxes, 2 mins, what?
This, but I still got the same answers.
Yes.
Why does it look different?
Because what I graphed was the derivative. You graphed the original. But you'll still get the same values. Because technically, to find the maximum values, you can set the derivative equal to 0 and find those x values. That's what I did. It's the exact same thing if you were to graph the original function and just find the maximum and minimums regularly. We'll still end up with the same value. So yes, yours is going to look different because you graphed the original function. I graphed the derivative. That's the difference.
For mine, I had to do like the left bound and right bound for each one. How did you do it just one?
Because all I was doing was looking for the intersection between this function right here, and 0. So if you're going to use the derivative, then you can use the intersect feature. But if you're going to use the original function, you need to use the maximum and minimum features of the calculator instead. So depending on which method you decide to go through, you're going to end up using different things. Okay? Other questions? Negative 3.08 was a what? Was it a max or was it a min? Are you sure? Okay. Another way you can look at this point right here. I go from being positive to negative. Positive and negative is a max, is it not? For this one, I go from negative to positive, which makes it a what?
Can't you go from positive now?
You read from left to right. So that's why you go that way. Questions on this? Yes?
So why do you graph it that way versus graphing the original and calculating the maximum?
Because doing the intersect feature for me is easier than trying to go left bound and right bound and then guess. And then going back through and then having to scroll down to go left bound and right bound and guess. Versus just moving over and enter. So, and plus, a lot of times, like this is like the 3% chance that it's not factorable. A lot of times any other projects we have been factorable, so this would have been easier route. Other questions? All right, before you guys work on this, what's the derivative? 3x squared plus k. K times x just leaves you with k. That's a constant. It says the curve has a local minimum at a point where x equals 2. If it has a local minimum where x equals 2, that means the derivative equals what number? 0 when x is 2. So you plug that in and you're able to solve for k that way. What's the value of k? Negative 12. This is 0 equals 12 plus k, so k is going to be a negative 12. Again, you set the derivative equal to 0 whenever you have a max or a min, and since you knew that x was 2, you had to plug that in to find k. So now that you know your equation is y equals x cubed minus 12x, you can find the y value of the minimum by doing what? Plugging in what? Plugging what into your original equation? Your x value of 2. So when you do that, you'll get 2 cubed minus 12 times 2, which is what number? And that is the y-coordinate of your minimum. You could also confirm that by graphing the original function and seeing that the lowest value is negative 16.
I thought you said graphing wouldn't work.
Graphing will work to help you find a minimum now that you have your function. But if you didn't know what k was, you couldn't graph it to figure out your minimum.